Welcome to the Emerging Technology Forum of Plastic Recycling, jointly organized by IPI Singapore and Helsinki Business Hub. My name is Yuming. I'm from IPI, and it is my pleasure to be the host for you. Today, we have gathered 6 speakers from both Finland and Singapore to share the demand drivers, business opportunities, and emerging technologies for collaboration across the plastic recycling value chain. Just a little house rule before we get started. We'd like to make this forum as interactive as possible, although all attendees will be muted throughout the session. If you have any questions during the presentation, please feel free to type them into the Q&A panel. We'll bring them up for our speakers to answer towards the end of the forum. And the presentation slides can be downloaded upon the completion of a post-forum survey, which we will email you after the event. Sounds good? Without further ado, now let's invite our first speaker, Mr. Go Seung-taek, Head of Manufacturing, Infocom, and Built Environment from IPI. Seung-taek will kickstart the session with an introduction about IPI and share with us the various initiatives IPI is working on for our companies to embrace open innovation and technology. Welcome, Seung-taek.
Thank you, Yumin, for the introduction. Good afternoon, everyone. My name is Seung-taek. I want to thank you for joining us at this Emerging Tech Forum. So allow me to share my slides. Okay, so to kickstart the session, I would like to give a brief introduction to IPI and our programs to help companies leverage on innovation as a business strategy. IPI was set up in 2011 by the Singapore government as a neutral intermediary to catalyze innovation in Singapore enterprises. It's actually our 10-year anniversary this year, and over the years, IPI has been supporting Singapore companies by facilitating connections with ecosystem partners and other co-innovation avenues. By accessing to these external resources, companies are able to develop new solutions, solve problems faster, at lower cost and risk. So the team at IPI comprises of technology and innovation managers covering multiple technology sectors and domains. My colleagues all come with industry background and they have experiences in areas such as healthcare, electronics, food science, and so on. The diverse backgrounds and experiences in the team allows them to better appreciate the needs of companies and clients, and especially when accessing technologies of interest. So over the years, IPI has built up an extensive network of partners. We have strong links with academia, research institutions, as well as intermediaries and agencies globally. IPI is a member of the EEN, or Enterprise Europe Network, which is the world's largest innovation and business support network. And this has proven to be an excellent source of technology offers and market needs, which the team readily shares with companies that we are in touch with. So if you go to IPI's website, you'll be able to see some examples on successful innovation partnerships facilitated by IPI. So what I would like to highlight here is the many different modes in which open innovation collaborations can take place. So for example, in these cases here, the collaborations may range from a JV partnership between 2 Singapore companies to develop a new software platform, or a project collaboration between a homegrown company and a Dutch technology firm to create a higher value product. And in the last example, we see a case where a Singapore startup worked with researchers from a local research institute. So what's the common point with all these examples is that these companies were all able to accelerate their innovation process, and they do so by leveraging on external expertise, external partners, instead of doing everything in-house. I would next like to give an overview of IPI's platforms and services, and the various modes in which we support enterprises on their innovation journey. So here we have a snapshot of IPI's portfolio of innovation services. Over here, open innovation services, that's where we engage companies one-to-one through modes such as technology scouting, and we also carry out technology landscape studies on particular topics of interest. And companies at a certain growth stage, they may also benefit from connection to strategic advisors, and we do that through an innovation advisors program. I'll talk a bit more about this later slide. And we also have an innovation marketplace, and that's where you can find curated technology offers, problem statements for you to look through, and if they are relevant to your needs, you can always reach out and we'll be happy to facilitate the connection. And on the events front, our annual flagship technology industry brokerage event, Tech Innovation, that's where we foster collaborations between international and Singapore tech providers and seekers. So on technology forums, just like today, we are delighted to partner with Helsinki Business Hub for this emerging tech forum. And this brings together potential partners from both Singapore and Finland. So all these are examples of platforms where IPI readily shares knowledge and useful insights with companies to help them explore new technologies and business opportunities. So just to elaborate a bit more on our open innovation services. So technology scouting is where IPI supports companies to actively seek out suitable solutions and partners. And the aim is to speed up projects, plug development gaps, possibly explore technology licensing. So over the years, actually, we've developed a lot of trust and a close relationship with some of our clients. And that also means that we sometimes function as their external tech scout, and we keep them abreast of interesting technologies. So IPI's technology landscape service, that's where we help companies deep dive into certain topics and to uncover opportunities or competition, and actually that helps them to in their strategic and investment decisions. So increasingly, corporates and government agencies also see the value of crowdsourcing for solution providers to their problem statements, and IPI provides the platform for these innovation challenges, so that the end goal is that driven by these needs-driven problem statement, good partnerships and strong commercial outcomes can be derived for the participants and the solution providers. So just a bit on the Innovation Advisors Program. This is where companies can gain access to a pool of innovation advisors. And these are people who are well-versed in technology and business aspects. They are industry veterans, possibly former C-suite executives or business leaders. And this is a bespoke program, so it supports companies with customized advisory, and it engages the company's management to jointly develop a go-to-market and project execution strategies. So the innovation advisors, or we call them IAs, they can help open doors, identify gaps, opportunities for companies, particularly when there's interest to pivot into new business areas. So do reach out to IPI if you want to find out more on the IA program, and the team will be happy to share a bit more with you. Some of the audience, you might be familiar with the Innovation Marketplace. As I mentioned earlier, it's a repository of tech offers and needs. There's from a wide spectrum of industry, wide spectrum of domains, and these postings are curated by IPI, and they come from both local and overseas parties who are seeking potential collaboration. So if you are a tech owner and you're looking to monetize your IP, this could be a useful platform for you to reach out as well. So you can also subscribe to our free weekly Tech Alert newsletter to receive up-to-date info on new postings. So through events like today's Emerging Tech Forum, IPI regularly shares market and technology insights. And usually this is on an emerging topic. And we also publish white papers. They are free for download. So past forums include diverse topics such as lithium-ion battery recycling and indoor air quality. So through all these events and publications, we highlight business and possible co-development opportunities. And these are partnerships which IPI will be happy to help facilitate. So I'm on my last slide, and this is just an overview of the various open innovation challenges that IPI have supported clients such as government agencies and corporates. So stay tuned, there's a link at the bottom. Stay tuned to upcoming challenges, which may be useful avenues for companies to seek out demand-led opportunities. So I've come to the end of my presentation. Feel free to reach out to any of our IPI colleagues if you have technology needs or offerings, and I will be happy to have a conversation with you. So I'd just like to hand over to Yumin, who can lead us on to the next segment of the forum.
Thank you, Seung-tae.
Over to you.
Thank you. Yes, if you're interested to work with us or collaborate with us for any tech partnership or collaboration, feel free to email us at events@ipisingapore.org. Next, I'd like to introduce our second speaker, Stephen Lee, Innovation Manager, Manufacturing Infocom and Built Environment from IPI. Stephen will be giving the presentation titled Market and Technologies on Plastic Recycling. Excited to find out more? I'm excited. Let's invite Stephen now.
Right. Thank you, Yumin. Thank you so much, everyone. It's good to see you here. And thanks for your support in advance. So let us begin. So good day, everyone. This is Stephen from IPI. I would like to share with you an overview of market and technologies on plastic recycling. So before I continue, I'd like to share with you the motivation that leads to this study. This is the Great Pacific Garbage Patch, a collection of marine debris covering an estimated area of 20 million square kilometers. This is more than 27,000 times the size of Singapore. The marine plastic problem is even closer to home. With the advancement in technology and waste management infrastructure, I strongly believe that we can do better in reducing plastic waste. Could we stop waste from leaking into the environment? Could we transform waste into valuable products or feedstocks? I would like to contribute here by offering you some observations gathered on the plastic recycling market, technology, and collaboration opportunities. Let us begin with market trend and drivers. Plastic has been in our lives since the 1950s with about 8.3 billion tons created. However, only 9% is recycled due to low collection rate and its inherent low value, among other reasons. In monetary value, this translates to about 6 billion annual loss for not recycling plastics in 3 Southeast Asian countries, Malaysia, Thailand, and the Philippines. This is a significant untapped business opportunity. China is a major importer of plastic waste, but that is before 2018. In January 2018, the country has imposed a strict waste import ban. As a result, it is expected to displace about 111 million tons to other countries, especially Malaysia, Thailand, and Indonesia, triggering a series of import bans by these countries. In Singapore, the export of contaminated, mixed, or non-recyclable plastic is restricted. This is due to the country's obligation to the amended Basel Convention, which affects waste declared under HS Code 39.15 series. Thus, we foresee that the import-export regulations may stimulate the demand for solutions to recycle plastic at source instead of export. Using patent filing trend as a proxy, we observed that the waste ban in 2018 may have accelerated the development of plastic recycling technologies. In addition, we also observed increasing demand for recycled plastic content in packaging by 2 groups of demand drivers. The first group is the regulators, which have mandated increased percentage of recycled content in beverage containers. Interestingly, Korea has already permitted the use of 100% chemically recycled PET for food contact use. The other group of demand drivers is the fast-moving consumer goods manufacturers, which committed to a significant use of recycled plastic content in their packaging. All in all, these have driven the market demand for recycled plastic resin. Singapore has adopted 3 key approaches: the deposit refund scheme that incentivizes waste collection, which will be implemented from 2022. We foresee that this will increase collection rate of post-consumer plastics. Next, the country is also active in developing recycling technology pilots, including a plastic recovery facility for general and domestic waste, pilot project to convert plastic to pyrolysis oil, or known as new oil, as a feedstock for chemical plants, and a feasibility study on chemical recycling led by NEA and Shell. This will catalyze the development of chemical recycling technology. The third approach is the packaging reporting framework, which mandates companies more than 10 million turnover to report on the amount of packaging they put into the market. This will be implemented from 2021. We expect this will enhance packaging waste data availability to guide decision-making. To summarize, we observed that from regulation perspective, the export-import ban may stimulate demand for localized recycling solutions. At the same time, governments and FMCG manufacturers are driving market demand for recycled plastic resins. Lastly, we also observed that chemical recycling is receiving strong interest at the national level. Next, let us go through the plastic value chain, and then I will share a few key observations. Plastic is produced by petrochemical producers in the form of polymer pellets. It is then converted into films or molded packaging used in consumer and industrial products. Ideally, the used plastic is collected by public waste collectors, sorted at material recovery facilities, and then recycled. Finally, for difficult to recycle plastic, it is usually incinerated and the incineration ash landfill. It is observed that there are increased collaborations across the value chain for two purposes. First, giving plastic a second life. The chart shows two partnership examples in the UK and Japan, which focus on converting waste plastic into food-grade packaging. Next, I would like to share with you two more examples for recycling technology pilots in France and UK, which focuses on pyrolysis and depolymerization. From the patent ownership perspective, we observed that FMCG manufacturers, petrochemical producers, and recycling technology developers own the most number of patents. These patents are filed in countries that have high level of developmental work, including France, Japan, and the UK, as highlighted earlier. In a nutshell, we noted that the rising demand for recycled plastic may have promoted partnerships across the value chain. There is also a strong focus on recycling waste packaging into food-grade packaging, a consistent move to meet the rising demand. Most of these partnerships are led by key players from countries that are also active in patent filing, for example, France, Japan, and UK. In the third section, let us dive deeper into plastic recycling technologies. Based on secondary research, about 60% of plastic waste comprises packaging material. Packaging material may come from post-industrial or post-consumer sources. There are 7 types of polymer materials in the market, of which LDPE and PP have the largest market share. But PET and HDPE are more widely recycled. In general, there are a few recycling challenges associated with each type of polymer material: multilayer, color, and contamination for PET and HDPE, multilayer, ink, labels, and odor for LDPE and PP. All in all, these challenges form the technical considerations in selecting suitable recycling methods, which I will share with you in the next slide. Waste plastic will first have to be collected, followed by sorting. For clean and homogeneous stream, waste plastic may be treated by mechanical recycling, where it undergoes shredding, washing, drying, extrusion, and compounding. For plastic not suited for mechanical recycling, chemical recycling may be employed. It is further divided into 3 types of chemical processes that target different polymers. Solvent-based recycling, where the target polymer is dissolved with chemical solvents. Depolymerization, a process that converts polymers into monomers. Pyrolysis, a heat treatment process which converts plastic to oil. Polymer material is obtained as a product from mechanical and solvent-based recycling, which can be used by plastic processes. Monomers and chemicals are obtained from depolymerization as raw materials for polymer producers. Diesel and naphtha may be produced from pyrolysis after purification, which can be fed into petrochemical plants. Taking a closer look at the market share, it is forecasted that pyrolysis and mechanical recycling will generate the biggest profit pool through 2030. Now, let us zoom closer into the profitability and technical considerations for different recycling technologies. As an established method, mechanical recycling is the most profitable, but it requires sorted, single type of plastic input. Depolymerization generates a relatively smaller profit, mainly due to high capex in setting up the process plant and high opex with chemicals consumption. Nevertheless, this method produces a high purity product stream, although it is limited for PET and polyamide. Lastly, pyrolysis is a versatile method that can handle mixed polymer. However, it usually produces low purity pyrolysis oil. Coupled with downstream refining, it may present direct competition to crude oil, in which the average price is hovering at $60 per barrel. As an example, our study suggests keeping the total production cost of recycled PET polymer at below US $800 per ton to ensure business viability. I hope the earlier sharing gives you a better overview of plastic recycling technologies and some of the technical considerations. Next, I would like to introduce to you a few collaboration opportunities for your consideration. First, I'd like to share with you a mechanical recycling technology developed by a startup from Spain. This method relates to a mechanical delamination device and solvent that separates multi-layer films. It is suitable for different types of laminates with ink and labels. The technology owner is seeking technology licensing and test-bedding collaborations. To find out more, please scan the QR code with your mobile phone and submit an inquiry to IPI. We'll be happy to have a conversation with you. The next technology is a solvent-based recycling technology developed by a university in Singapore. The method uses photocatalyst and solvent to break down shredded PE plastic into formic acid. A key advantage of this method is that it avoids harsh alkaline pretreatment steps. The technology owner is seeking technology licensing and research collaborations. The third technology is a depolymerization method developed by an enterprise from Korea. The method relates to glycolysis of PET into oligomer, which is suitable for UPR and PU synthesis. This approach is able to process contaminated sources with a few pre-treatment steps. The technology owner is seeking technology licensing and joint venture collaborations. Last but not least, an integrated process to pyrolysis that developed by a university in Singapore. This method relates to a catalytic process that synthesizes carbon nanotubes from non-condensable gases formed during pyrolysis. This approach is suitable for PE and PP sources. The technology owner is seeking technology licensing and research collaborations. I'll let the next speaker, Dr. Andre, to share more with you about this technology. In the final section, let us look into emerging technologies on the horizon. Based on patent distribution by technology type, there is a high level of patent filing activity in mechanical and chemical recycling technologies, a trend that is consistent with the market share forecast discussed earlier. Expanding the table to cover the target materials, it is noted that conventional approach mainly focus on single type of polymer material. We have also identified 4 emerging technology areas, including multi-layer separation, enzyme-based depolymerization, microwave-assisted pyrolysis, and post-recycling purification. I will share more in the next slide. For multi-layer separation, it involves separation of multi-layer film with proprietary solvents. This method may require the use of adhesive that is compatible with the solvent and may be complemented by sorting and shredding. Here are some of the technology owners that focus on this area. The next technology involves the use of enzyme. For example, esterase, lipase to catalyze glycolysis reaction. The enzyme may replace metallic or alkaline catalyst and is able to improve degradation yield to more than 75%. However, enzyme-based reaction may require a longer reaction time with a mild reaction temperature. Here are some of the technology owners that focus on enzyme-based depolymerization. Microwave-assisted pyrolysis uses silicon carbide catalyst that absorbs microwave energy to improve energy transfer, which results in reduced processing time and energy consumption. This method is designed to handle mixed or single type of polymer. Here are some of the technology owners that develop pyrolysis-based technology. Lastly, pyrolysis oil refining is another emerging area, which purifies pyrolysis oil with organic solvent and catalyst mixed. The refining method reduces solids, gum formation, and yields up to 95% of diesel and gasoline at mild reaction temperatures. Similarly, here are some of the technology owners that specialize in this area. I hope that I have given you a clear overview of the market trend drivers, value chain, recycling technology, collaboration opportunities, and emerging technologies. Here are the key takeaway points for your reference. First, the international export-import ban have stimulated demand for localized recycling solutions. At the same time, the increased demand for recycled plastic content has catalyzed technology development activities over the last 5 years. We also noted that there is a strong interest on chemical recycling from key players across the plastic value chain. Emerging technologies in general focus more on environmentally friendly and energy efficient methods. Last but not least, for technology adoption, companies must consider the total cost of ownership, waste management infrastructure, and the product value to ensure that the recycling business is viable. Looking back at the patent filing trend, which may be triggered by the waste ban, it tells us that companies tend to be more reactive to regulatory changes. Often, technology development from proof of concept to commercial scale takes a significant amount of time to materialize. As such, we urge companies that aspire to develop or adopt recycling technology not only to start early, but also starting strong with relevant insights. We would like to invite all to register your interest to download our white paper and look forward to have a conversation with you soon. I hope the content has been useful for you. Please help us improve by filling out the survey form after this event. We also look forward to your participation in the business matching sessions. Thank you for your attention.
Thank you, Stephen. I'd love to find out more about your white paper. And for the audience, if you're also interested in the white paper, you can register via the link shown in the Zoom chat later. Next, I'd like to invite Dr. Andre Verksha, Senior Research Fellow, Residues and Resource Reclamation Center from Nanyang Technological University. He will share with us about the carbon nanotubes technology. Please, Dr. Andre.
Hello, everyone. Thank you for this introduction. Let me share my slides with you. All right. I represent Residues and Resource Reclamation Center of Nanyang Technological University. Our center works on the development of thermochemical waste treatment technologies such as gasification and pyrolysis, with the aim of using these processes for solid waste management. Our main goal is to improve and develop new thermochemical waste recycling processes in order to reduce pollution, replace landfilling and incineration with more advanced technologies that can recover resources and materials from waste and also shift economy to circular model. And what is also important is to find ways how to make recycling process economically sustainable. Some of you may have heard about pyrolysis process, just now Steven introduced. So during pyrolysis, plastics are heated to high temperature in order to decompose polymers into smaller fragments. The main product is pyrolysis oil. There are also gases and carbon black produced as byproducts. Oil is the main product that can be used either as a fuel or chemical feedstock. And good thing about pyrolysis is that it can process mixed plastic waste. The problem is that oil prices are currently low, and this results in low profit margin of pyrolysis process. In fact, there were attempts to operate plastic pyrolysis plant in Singapore a few years back by one of the local companies, but after several months, the plant was shut down and decommissioned. The technology that we developed is an add-on process to pyrolysis plants. That means that waste plastics can be converted to pyrolysis oil first, and then only remaining gases are utilized for chemical synthesis of a new product. In our process, gases are converted into carbon nanotubes and hydrogen-rich gas. Carbon nanotubes are high value product. They can be used as an additive to various materials, for instance, to make lightweight plastics or high-performance batteries, also additive to smart textile. And attractiveness of carbon nanotubes is in their price, which is much higher compared to plastic feedstock, compared to oil and other byproducts. Using technology that we developed, it's possible to produce approximately 100 kilogram of carbon nanotubes from 1 ton of plastic waste. And considering the market price, this gives a substantial increase in profit margin. Additionally, there are also environmental benefits such as reduction of carbon dioxide emissions. To give you an idea about the benefits, on the left side, there is a table with inputs and outputs for treatment of 1 ton of plastic waste using pyrolysis only and pyrolysis plus carbon nanotube synthesis process. And this table demonstrates the increased gross margin due to conversion of plastic waste in carbon nanotubes compared to conventional pyrolysis process. On the right side, there are data from life cycle assessment process showing improved climate change potential of the process due to conversion of industrial gases into carbon nanotubes during this process instead of their combustion. There are 3 steps for manufacturing of carbon nanotubes. The first is synthesis. This is a process that converts plastic waste into nanotubes and also controls properties of material. The next step is purification, which is used to remove catalyst residues from the material. And the third step is purification, modification, which is required to modify the properties of nanotubes and make them suitable for dispersion and mixing with solvents and resins. And often synthesis of carbon nanotubes is carried out successfully, but purification and modification are not done properly. As a result, carbon nanotubes with low quality are obtained that are not suitable for any applications, like for instance, for battery manufacturing. In our case, we focus on all 3 aspects of carbon nanotubes manufacturing. We developed processes for synthesis, purification, and modification. and this allows us to manufacture product with very low heavy metal content and good dispersion. Currently, technology is being tested using fully operational prototype. We have built a pyrolysis and carbon nanotube synthesis system that produces both pyrolysis oil and carbon nanotubes from plastics. With this system, we are able to manufacture samples for testing by potential customers and optimize process conditions. Carbon nanotube output is currently 50 to 70 grams per day. Here on the left side of the slide, you can see two main types of resins that are typically used for pyrolysis. These are polyethylene and polypropylene resins. We get it from a local recycling company. Next to resins are pyrolysis oil and carbon nanotubes. While currently we work with polyethylene and propylene feedstock, in future we will be expanding this technology to mixed plastics. We have already run tests using flexible plastic packaging and marine plastic litter, and the results are quite interesting. One way to bring this technology to life is to proceed to piloting and test bedding at a larger scale. We are open to work with suitable partners who have interest in this technology. With this slide, I would like to finish my presentation. If someone is interested to continue discussion, my contacts are below. Thank you everyone for your attention.
Thanks, Dr. Andre. Very interesting. I guess waste is also a 6 billion business opportunity for all of us. If you have any questions for Dr. Andre, feel free to submit them in the Q&A panel. Now, let's invite our next speaker, Ms. Irma Ilikangas, Senior Business Advisor from Helsinki Business Hub. Irma will give us an introduction to Helsinki Business Hub and the circular economy ecosystem in Finland. Irma, the floor is yours.
Thank you, Yunmin, and thank you very much. I'm really honored to be here as one of the speakers, and I really want to thank you, IPI, for the good cooperation, what we have been doing over 5 years. But let's have a quick look about the Helsinki Business Hub and the circular economy ecosystem in Finland. So Helsinki Business Hub is the international trade and investment promotion agency in the capital region. And we help foreign companies to set up their businesses, grow and develop in Helsinki. Also, we show them innovation ecosystem, which is around if they want to be part of that. And because we are a public organization, our services are free of charge to all our international customers. We work in 3 different areas like ICT, smart and clean, and health industry. Today we have focus on the smart and clean area, and especially there in the circular economy and plastics. We also offer investor services. So companies, we share information, connections, but tell about the business opportunities in Helsinki, and also piloting opportunities. There's new area like testbed Helsinki side, where the city offers several areas where companies can come and pilot their solutions. We work with the investors. We have a deal flow for about more than 1,000 Finnish companies, which are looking for investments in all different areas. And startup ecosystem is very, very active in Helsinki. So again, we will connect you to the startup ecosystem if you work like a startup. And now a little bit about the circular economy and some innovations and practical examples about those. Finland has been quite leading about the circular economy, and it was actually the first country which made the circular economy roadmap, and that was 5 years ago. And Finland has also very ambitious goals to be a global leader in circular economy. So there's a large program to promote circular economy, and wish to be a circular economy country by 2035. This UNICO program also includes some citizens. So there was a randomly selected volunteers who could give also their input. And also in addition, the Finnish citizens were invited through online brainstorming to proceed in this platform. Helsinki City has also approved the Carbon Neutral Helsinki 2035 action plan. And in that plan was also an idea to decide the circular economy roadmap for the Helsinki, which was published a year ago. In this circular economy roadmap of Helsinki, Helsinki wants to put attention about the unnecessary use of plastics. And also it will actively follow how much of recycled plastics and materials are used. And if there are any other materials that can replace plastics, they can be also taken use. Of course, plastic is also good in several applications, so not all solutions should be replaced. And there are, again, a lot of new solutions which could be piloted and adopted on the city test basis. Also, this circular economy and the carbon neutrality plan not include only use of plastics and so on. Helsinki also wants to put education, the circular economy part of the education, like in early childhood and basic education too. Also, we want to bring our ways to curb the climate change, and other areas of interest are the urban farming and tackling food waste as the overall in the circular economy. So next I will show you a few examples about applications. I mean, this is a trash bin, which is a very deep, and it is crane operated only. So, the driver who picks up the waste uses a joystick to empty the containers. And this happens very fast, so it takes about 1 minute, a little bit more than 1 minute to do. And what kind of advantage this brings to the users? Of course, it saves a lot of property space because this is deep system, and then because it is a large waste collection system, it also reduces number of emptying rounds. So you don't see the trash cars that often on the roads. And deepness also brings the physical laws. So the natural compression maximizes the volume in use. And because it's below ground, it also cools. So the odor is not that extensive that it could be only on the surface trash bins. And they look nice. And of course, there's a lot of sorting going on already in Finland, and in these kind of trash bins you can find the sorting, like looking for the colors where you should put your efforts there. It's not only on the land where we use trash bins or need to collect the trash, and like Steven started his presentation showing about the big problem what we have in seas. We have there also a solution from Finland called Klevat. Klevat is actually a vessel system which has a boom in front of this boat where water and the waste is collected. It flows through this boat, and according to adjustment of the water speed, the different phases of trash is separated for these waste containers, what you can see beside the vessel. And one of the advantages is that it's not only for the big trash, what is in the water, but it's also very small. As you see, the smallest size, what it can collect is about 0.5 millimeter particle sizes. And in addition for plastic, it can be also used for plant collection or the oil recovery from the seas. Then we also have an AI-based waste sorting robot. They have two kind of, there's just two examples of them. There's a heavy picker and fast picker. Heavy picker is designed more in the industrial ways where you need to lift them with the strong lifters like metals and heavy parts. Then the fast picker is mainly for consumer goods, but it uses a vacuum to sort the waste. This sorts, of course, different fractions of metals. They are so metals, wood, plastics, but it can also separate different polymers, like Stephen mentioned in his presentation. There are polyethylenes, polypropylenes, and so on. So this can be used to separate different polymers, also different shapes or the size or the color in there. So this is really suitable solution also for sorting the plastic waste. And of course, everybody understands that these robots work 24/7, so it increases productivity, increases, fraction purity, recovery rates, and so on. And of course, then there's no human who needs to touch them, of course, in the end, but during the process, the robot takes care about the most of the waste sorting. Then I want to show you some consumer products from Finland. This is just simply sorting station, I would say, for the private homes. It has 3 buckets inside. This is mainly for like paper waste, cardboard, and let's say clean plastic, for example. But what is neat in it, you can also use it as a seat or chair in a kitchen or any other place in your apartment. It can carry about 100 kilograms weight, so it's a very good tool, and it looks quite nice. This is from the Orthex company, who is really doing using a lot of recycled plastic for consumer products in Finland. Then we have also a nice packaging solution here, which is called Camelbak, also from the Orthex Group. They use these for food delivery. It's not one use only, so you can get the deposit when you return it back to your the food store or the restaurant where you have purchased your food. The washing is done inside the restaurant, and then it can be reused for the next packaging. So it diminishes the use of plastics, and it's reusable for several times. And one more, just a simple example. So there is fishing nets which are made for buckets for future, but there's a lot of recycled solution available already for consumers in Finland, and we can see an increasing trend of using them. And last but not least example is a company called Block Solution. They make blocks to build houses or fences or barns or so on. And what is nice in here, it is very light, but still quite good for housing purposes. They use either recycled plastic or biocomposite to build houses. And here is an example about the house, what they have built. It is also very affordable. And it can be also used when there has a natural disaster happened, because they doesn't take, it's less than a day, probably 8-9 hours to put this up. And there would be a safe housing and nice looking housing where you could build. Of course, this could be used also in open areas where you want to have a place for people to visit or other purposes also. So we would really like to cooperate with Singapore in the recycling area and circular economy area. Why and what we can do in Finland, in addition for the plastics and plastic recycle. Finland has been ranked for #1 in bio-based circular economy and also wood cellular-based fibers. And so it's not only plastics or the circular economy, it's a lot about the bio-based materials where is the know-how, also in a paper-like materials for packaging, food packaging, and also storage boxes for department stores and so on. And what we always want to advertise that, of course, Finland was 4 years on the row, and again this year the happiest country in the world. So you can also work with the happiest people in Finland and with all the technological know-how what is listed in here. Stephen also mentioned that we will have the matchmaking in May coming. So if you are interested about cooperating any plastic related or any other related companies, we will have 3 sessions coming, and more information about these will be shared after this event through emails for all the participants. So I want to thank you, and if you want to have more information about the circular economy in Helsinki, we have just recently published a guideline, so it is freely downloadable from our web pages. Thank you, and I hope you enjoy the day of sharing data from Singapore and Finland.
Thank you, Irma. Please share with us your secrets of happiness next time. Next, let's invite Ms. Tuula-Mari Halaya, Vice President, Energy and Chemistry from VTT, to the stage. She will speak on the topic of circular economy solutions and particularly plastics chemical recycling, an area I'm sure many would be keen to find out more. Ms. Tuula-Mari, please.
Thank you for the very kind introduction, and I'm very happy to be here and tell you a little bit about VTT and our activities in the field of chemical recycling of plastics. And now let's see if my presentation works. Can somebody confirm, please, that if it is okay, or?
Klikkaa sieltä ylhäältä.
Mikähän kohta se nyt oli?
Display settings ja ykkösvaihtoehto sieltä.
Swap. Yes. Now it's better?
Yes.
Okay. Okay, so I will first tell you very briefly about VTT, then introduction to our circular plastics vision with some facts and figures, and then the actual technology development, what we have been doing at VTT. And then I will end my presentation with describing you a little bit that how does our testbed research infrastructure look like for chemical recycling, and then some key takeaways as well. So what do we actually do at VTT in practical terms? So VTT is a visionary partner for research, innovation, and development, and we help enterprises and the whole society at large to put new science and technology into practice. And if you look at the next slide here, you see some key figures from VTT. So we are a significant international research institution with around 245 million euros in funding. And we are a major player in Finland, but not only in Finland, but more than 1/3 of all, almost 50% of our turnover comes from abroad. But in Finland, more than 1/3 of all our Finnish innovations involved VTT, some of our expertise, and we employ more than 2,000 people at the moment. Then moving a little bit ahead to the actual topic. So here you see the circular economy of plastics, our vision. So from a daydream to reality, what does it take to achieve that? And of course, there are many factors affecting how to put everything into practice. But if I should simplify the picture, I would group it into 4 categories. So it's about design, it's about broadening of the feedstock base, it's about developing different recycling technologies, and last but not least, it's about collaboration. And collaboration in a very broad sense. So within the whole plastic value chain, as we have heard today already from the earlier speakers, and then really creating ecosystems around it. And at VTT, we have developed, for instance, different type of tools to achieve better design from the very beginning of the product development. And one of our tools is called Propotune. And it's a kind of optimal computational material design, which also shortens time to market for new products by an average about 50%. We have also developed other tools, like recently launched Plastic Compass, which helps companies to select the best material based on your needs and desired material properties. Then Irma already mentioned about different feedstock, in a sense that we have this bio-based feedstock around us in Finland rather extensively, thinking about all of our forest and forest biomass. Then of course it's about these alternative sources from industrial streams like CO2, and then from different type of waste fractions. So plastic waste is one of the new feedstock making this circular economy into alive. I will talk in a short moment about the recycling technologies, but I still would like to emphasize this collaboration. So we need to bring the whole value chain to work together, including private sector, public authorities, and also citizens, to really make this circular economy of plastics a reality. So we already heard about the business opportunities regarding plastics recycling, but if you think that globally around 400 million tons of plastic was produced in 2019, and it's predicted to reach 1,000 million tons in 2050, there is surely a lot of things we can still do and have different type of business opportunities, and also thinking about the fact that around 10% of the materials are now recycled. And based on the chemical recycling estimates, it's estimated that in the coming decade, it will increase around 30%. So some of the technologies at their infancy at the moment will really be extensively increased in the near future, especially chemical recycling and pyrolysis. Okay, moving on now to what do we have at VTT. So basically we have these three options. We have biotech, mechanical, and then chemical recycling. And each of these is in a different phase. I will now share with you just a little bit around this mechanical recycling, what we have currently developed, to highlight the kind of combination of the technologies, what is really needed. So this slide here tells you the idea for the value retention of plastic waste. It's after this mechanical part of collecting, sorting, and pre-treating the waste, we do thermoplastic processing in a way where we can control online the melt flow and viscosities of the melt plastics. And in this case, we need to tailor those properties. We can do that by this smart repair unit, which is depicted in the slide. And really the benefits of this system is that it can be integrated into existing processes, and we can control and enhance the quality of recycled thermoplastics, and in this way increase the value and the utilization rate of recycled plastics. But now if we actually move to the chemical recycling, what we have at VTT, so our vision is to develop chemical recycling of plastic waste towards monomers and in general into refinery feedstock for producing chemicals, fuels, fuel components, and monomers for plastic materials. And we have two thermochemical recycling technologies for plastics waste, namely pyrolysis and also gasification. And I will tell you briefly about these next. So VTT has a strong know-how and over 35 years experience on pyrolysis R&D. We have, for example, commercialized fast pyrolysis of biomass together with Finnish industry. And our focus is now to apply all these expertise of pyrolysis to industrial plastic containing waste to provide value-added products. Some of our recent highlights are described here. So first I would like to mention Modix, which is a modular mixer designed to pre-treat and compact waste streams, including plastics, cardboard, and wood-based materials for pyrolysis. The real benefit of this Modix system is that it minimizes the process steps due to the more compact way of raw material feed system, and it can process materials like films, which other machines can't do. And we have patented this Modix pyrolyzer, and the prototype has been built by our client and successfully tested also with plastic packaging waste. The second highlight I would like to mention is the chemical recycling of polystyrene waste to styrene monomers via pyrolysis, and we are exploring this with our partners. And the goal is to convert waste into pure polystyrene or styrene monomers used in other plastics and chemicals with the combined mechanical and pyrolysis technologies. And the resulting pyrolysis oil can really replace oil fractions when producing, for instance, aromatics, latex, polystyrene, and carbon black as well. We have proven that the virgin quality styrene can be attained from polystyrene pyrolysis, and one of our project partner, CH Polymers, has certified it for the use of their manufacture of latex. And last but not least, we are developing actively methods to allow a safe utilization and handling of different type of waste fractions. And as you all know, they contain different hazardous components and, for instance, flame retardants, and one needs to make sure that how to get rid of these components while handling plastic waste. Okay, then next for the gasification. Also in gasification, we have rather long experience, around 40 years, and 25 years of that in gasification of plastic waste. In the end of 90s, VTT developed for Corenso a fluidized bed gasification technology, which is capable to gasify plastic waste containing even 15% of aluminium foil. That technology was implemented in 50 megawatt scale in Varkaus, Finland, and it's still in operation. And the graphics here on the slide shows this gasification plant for Corenso Stora Enso that was designed and developed by VTT. And then we have also developed 2 decades oxygen and steam-blown gasification of wood-derived fuels in order to produce syngas for chemical synthesis, and then in that way to produce liquid fuels and chemicals. And this technology was demonstrated successfully 10 years ago together with NSC Biofuels. And now one of the main activity in development of plastic waste recycling based on gasification is really on our focus, and we are looking, in addition to conventional syngas route, other alternative process concepts as well. Here very quickly still plastic chemical recycling pros and cons. We have heard a lot already about these. So of course, clearly we can handle complex feedstock, and then we have a rather similar quality to virgin feedstock. These are great pluses, but then on the other hand side, we have the demands for energy intensiveness and infrastructure. And then depending a little bit from whom you ask, there are also different opinions if the use of fossil resources are really reduced, and if CO2 emissions are really reduced by implementing more and more recycling of plastic waste. But clearly there is a business opportunity ahead of us, thinking that the gasification and pyrolysis exist at a demonstration level at a smaller industrial size, and then require further innovation efforts before being rolled out for subsequent commercialization. So this is a great opportunity for us. Then very briefly still about our test bed in the southern part of Finland, in Espoo. It's called VTT Pyrolysis, and there are these technology platforms already in operation regarding process chemistry, gasification, pyrolysis, even hydrometallurgy and biomass processing. And in addition to all of these platforms, we have a rather extensive European collaboration network. And you are all very warmly welcome to visit us whenever the pandemic allows us to travel again. Still shortly some key takeaways. So if we really want to maintain the benefits of plastics in a sustainable way, we need to have circular plastics economy in place. And there is no one fits for all circular solution. I hope I have convinced you that we need a kind of combination of different recycling technologies to implement this circular economy to a large scale. And then chemical recycling will be one of the key things to implement circular economy, and we need to move away towards thinking of waste also other than plastic as a kind of new raw material to chemicals and materials and different type of monomers, and not only fuel components. And surely there will be some regulatory framework directives and implications to really boost also this kind of large-scale circular economy. But I would like to highlight that it's a more and more a kind of business opportunity. It's not about regulations, it's how do we make business out of that. And finally, I would like to thank you all for your kind attention, and if you have time to join another virtual event next week about plastics, you are warmly welcome. I will give a presentation there and tell you about the VTT Plastics Compass in more detail. Thanks a lot for your kind attention.
Thank you, Ms. Tulamari. Last but not least, I'd like to introduce our final speaker for this forum, Mr. Heikki Fakila, Vice President, Chemical Recycling of Plastics from Neste. Mr. Heikki, please.
Thank you very much, Jan. I want to thank Helsinki Business Hub and IPI for the opportunity to join today and talk about, talk a bit about Neste, a company that probably is well known to many of you, since we are present both in Singapore as well as in Finland. We are based out of Finland, but we have a strong presence in Singapore and actually are just in the process of completing a major expansion of our renewable refinery in Singapore, an investment worth more than $1 billion. So a significant contributor to the economy, both in Finland and in Singapore. What I wanted to talk to you about today, though, was Neste's activity in the area of chemical recycling and the opportunities for collaboration in that domain. Before going into the presentation, just to confirm, is the presentation showing all nice and dandy to all of you?
Yes, it's very nice.
Very good. Excellent. So just a few words about Neste. Our legacy is in oil refining, based out of Finland, but already for more than a decade, we have been developing a renewable product range, building a global leadership in renewable fuels based out of oils and fats, primarily wastes and residues from veg oil, animal fats production. And with that, we have established ourselves as key helper of transportation, cities, in aviation, as well as polymers and chemicals, in making their business more sustainable. Looking for ways to move away from fossil resources, reduce the carbon footprint that our activity is leaving in our environment. What I focus on today is indeed our offering for the plastics industry and what we are doing there. A product we have labeled Neste Re, where we are providing the plastics and chemicals industries with 100% renewable and recycled raw material as a feedstock for plastics and chemicals production. So if you look at Neste's role in the overall plastics and chemicals value chain, we are not in the production of plastics, but we are working to provide a raw material platform for the plastics industry to adopt as, on one hand side, virgin quality material, but a drop into existing value chains, which is compatible with the production infrastructure, but equally importantly, it is similar from chemical point of view to the plastics that we are used to, and it is eligible for reuse and recycling alongside conventional plastics. So it's introducing no additional complexity into plastics collection, sorting value chains. The product includes two components. The one which is clearly more established today is the renewable part, where the product is based on the same Neste proprietary technology that we are using for producing our renewable diesel, renewable aviation fuel products, based on renewable oils and fats. And that's where we already have more than 3 million tons of capacity available, and it's growing. So the advantage of that is, of course, that we have a scalable solution to reduce the carbon footprint already today. What we are building alongside that as a complementary offer is the recycled component, which is based on chemical recycling. And I want to thank Mr. Lee for a very good overview of where chemical recycling is. Where what we are focusing on is recycling difficult to recycle plastic streams, colored, multi-layer films, multi-material packaging, to a drop in quality feedstock for new polymers and chemicals. And we are taking this very seriously. Already a couple of years back, we announced our ambition to process more than 1 million tons of plastics into raw materials from 2030 onwards. And we are very decisively executing on this pathway and working towards this ambition. Now, we've had already a couple of good overviews of what exists in chemical recycling. And I think it's very important because chemical recycling of plastics is by no means one solution. Just like we heard from Ms. Helaya before me, we will need a combination of different technologies. And from our point of view, the technologies are primarily not competing, but complementing each other. Liquefaction is where our focus lies, where we are focusing on mixed polyolefin-rich plastic streams, like post-consumer packaging, also post-industrial streams that do not find a good home in mechanical recycling. But it's important to remember that not all plastics are created equal. There are streams that are best fit for mechanical recycling and should go that avenue. There are a lot of mono polymer streams that may be best addressed by depolymerization, solvolysis, and travel back into plastics. But we are focusing on the avenues that are producing a liquid crude oil-like material for further refining and back into the chemicals industry. Now, what is Neste's role in all of this? If we look at where our core competence is and what we have learned already, the experience we've gained in the more than a decade of building up the renewable business, it is very much focused on collecting fragmented waste residue streams, pre-treating, purifying those to be good quality petrochemical products, and then providing those over to the industry to refine further. At the same time, our focus is very much on traceability of the whole value chain, of the sustainability of the value chain. And that's where our focus lies. So what we want to do when the industry sort of grows up is really be the best buyer for the liquefied waste plastic streams, the best upgrader for them, to be able to take in a broader range of different quality plastic oils, because not all pyrolysis oil looks similar from their chemical qualities point of view. We want to be able to refine those most efficiently, effectively, to then provide them as a combination with our renewable offering to the industry, and at the same time make sure that the brand owners can rely on the sustainability and the traceability of the value chain. However, if we look at where the industry is right now, today, what's probably the most short-term bottleneck for the scale-up of the industry is developing the liquefaction technologies. And that's why you may have seen us being very active also in that front. Last year, we established an investment and a joint development with two technology developers in this field, recycling technologies based out of UK, as well as then Altera Energy based out of the US. A bit different approaches to turning mixed plastic streams into a crude oil, into a feedstock. But both promising technologies, and what we want to bring into that collaboration is Neste experience, both in terms of what's required from safety and reliability point of view from these types of processes, as well as then the understanding of what's required from quality point of view to make the product a good fit for refining and petrochemical. Now, we've heard, I guess, and one hears in the market a bit contradicting tones from where the development, where the commercialization of chemical recycling technologies is. From our point of view, the solution is available already today, but indeed it is something which needs to be developed fast. We processed our first industrial scale trial of chemically recycled material in our refineries to further go into petrochemical feedstocks at the end of last year. A batch of 400 tons, which may be big or small depending on how you look at it. It represents the waste streams from approximately 20,000 EU citizens, but of course at the same time in the scale of refining and petrochemicals it is rather small. We are very much building this in collaboration with partners. We are working in waste management with Remondis and Ravago, who are well-established global players who know the waste collection, who know the mechanical recycling market, and with whom we are aiming to make sure that the solution we are developing is a realistic outlet for waste plastic qualities that can be produced from the existing collection chains, which is an important factor because converting pure polyolefin streams into a liquid product is not very difficult. But when you start going into actual waste streams, which contain a lot of different impurities, vary in quality over time, the challenge is multiplied. And that's why we want to make sure that we work with the waste management companies and continue to expand our range of collaborations there. We have our partners, as said, in plastics liquefaction, recycling technologies, Altera Energy, with whom we are developing the technology further and who are very keen on, of course, bringing those solutions broader to be applied across the globe. The target clearly with the liquefaction solutions is to create technologies that are valid for global applications. And when we go into steam cracking and polymerization, we have established relationships with Borealis, with LyondellBasell, with Covestro in the plastics value chain. And we are continuing to build that up and provide our solution of renewable and recycled materials to others as well. Now, since the focus of today is a lot around collaboration, we are very keen to expand our range of collaborations when it comes to waste management, to together develop capacities for liquefying waste plastic, and with our partners bring the technology solution for those needs, provide the offtake for the material by Neste, and making sure that we can be as flexible as current technologies allow, leading the market in terms of how broad we can be in terms of the range of materials which are used. We are still open for looking at liquefaction, purification, upgrading solutions for the pyrolysis oils. So while we have the established technology collaborations there, we are not closing our eyes for what's happening elsewhere in the market, and are very keen to hear about competitive solutions and provide Neste support for commercializing those, for advising on quality and reliability considerations. And finally, we are continually increasing our offering towards the petrochemicals companies. So for the renewable recycled product that's available, we are very keen to bring that to additional partners. I will thank you at that and hand over back to IPI.
Thank you, Heikki, for your insightful sharing. Now let's bring back all our participants and panelists for the Q&A session. We do have many questions already posted by our audience today. Yeah, thank you very much, everyone. I guess as someone who is new to the area, now all my plastic bags at home doesn't suddenly look very different from me. Okay, so let's start the Q&A sessions. We have many questions. I guess I will pick the first question for Stephen.
Yep,
So
sure.
Stephen, there's a question here. Are there any unique composition or structure of plastics from different manufacturers which can be used as an identification to help improve the traceability of used or recycled plastics?
Okay, yeah, thanks. I think thanks to Maggie Chan for this question. Very good question. So I think as to unique composition or structure, I presume that you're referring to different forms and different types of plastic material. So I think there is such combinations of possibly usage of a barcode or a QR code based. But I think this would very much depending on the waste management infrastructure again, to set up the traceability system and a waste management infrastructure that can recover the plastics. So it also involves things like logistic costs, of course, the back-end software infrastructure. I think to give an example here is, in fact, this is already in practice in many parts of Europe. So under the extended producer responsibility regulations. So within this EPR, they call it, producers are required to collect back a certain targeted amount of plastics they put into the market, and they are obliged to recycle them. So yep, the short answer is there is such a system to help improving the traceability. Thank you.
Very cool. And I guess we have another question. Is for Dr. Andre. So in preparation of CNT from plastic, what kind of catalyst will be good for it? So this is the question for you, Dr. Andre.
Thank you for question. Usually catalysts that are used for carbon nanotube synthesis prepared from three major metals, iron, cobalt, and nickel. Depending on how catalyst is prepared, characteristics will vary, and this will also influence yield and quality of carbon nanotubes. Therefore, not only composition, but also preparation techniques are important for that. And we tested different catalysts and come out with the most suitable ones that result in a good quality product.
I see. Understood. And we have another question, which is very interesting. So someone is asking, do you see any potential in what could be called the green margin for recycled plastics? This is referred to, so people who are being prepared to pay a premium for a product if they feel that they're doing some good for the environment as part of the purchase, which is this green margin concept. I guess I will open the floor. Mr. Heikki, do you want to answer this question?
Yeah, very happy to. I mean, if we look at the market for chemically recycled material, right now, I would say that indeed it is relying very much on the leading brand owners who have made their commitments, as you know, Stephen was highlighting, to adopt fossil-free materials. And the fact is that the cost for producing the materials is higher, at least for the time being, than the cost of using virgin fossil materials. So today, the green margin is a reality. You know, it is there, and that's what the initial market is built on. Of course, then what is highly uncertain is, how far will the market develop based on that? And that can be driven, by different factors. On one hand side, how far does, at the end, the consumer's willingness to pay and, value more sustainable materials carry the business. On the other hand, where the regulation is going. We are seeing, promising marks that, or promising signals that there are increasing mandates for using recycled content as well as increasing recycling rates. And both will at a certain point, push towards the, most cost competitive solutions. But, if those become then at a higher price than virgin fossil materials, then again, a green margin will be created more based on, regulatory drivers. So I much believe that the green margin will be there. It is a reality, but then the question of how fast it will be adopted is the one that, of course, everybody in the industry is very much, keenly looking into, to see how fast can we scale and how far will the willingness to pay carry the build-up.
I guess it's also related to the mindset change for the consumers, for the customers, right? Generally young people might have more, I would say, mindset in terms of sustainability or helping the environment. So yeah, we will see.
Yeah,
absolutely.
I mean, White rightfully pointed out this, if I may chime in here. I think another dimension to look at is consumer education, better consumer education, as well as better product design. So in fact, I think I wanted to cite an example from a survey by McKinsey done recently, saying that consumers are actually willing to pay more for green. Because in fact, if products are designed with better labeling or made available to them, and then with better awareness, I don't see a challenge here in making a green margin a norm. Yeah. Thank you.
I guess that's why, our plastic bag from NTUs in all the grocery stores is going to be charged from next year onwards. So yeah, we'll see. And we have another question for Ms. Tula-Marie. So could you share with us what's next for plastic recycling technology development? So your thoughts into this area.
Well, what's next? That's a pretty tough question. Yeah, but as I mentioned, we are developing these thermochemical routes further, and that are the most advanced what we have at the moment. But then on the other hand, I did not talk about these biotechnical solutions, what we are also developing. They are at an earlier phase, I would say, but thinking a little bit to the question which there is also for me regarding the sea plastic. Or from the rivers and from those surroundings. So I think that we need some local solutions. It does not make much sense to really transport very difficultly handling plastic waste to some very location on the other side of the world. But if we had a kind of a biotech solution for local sea or river sides, that would make sense to me. But that's now kind of free thinking. I don't have with me a kind of very detailed solution, but I do know that we are developing, and if the person who asked this question is interested to talk more, I will be happy to have a separate discussion regarding that topic.
Yeah.
And regarding the other technologies, what we are developing, especially gasification, that is something what we have done in a rather big scale and demonstration scale together with the industry. And as I very shortly mentioned, there are some activities which I am not allowed to talk publicly here, but we are looking into new concepts and developments also there.
Right. Yeah, I see a question as well. It's not realistic to always transport waste from one area to another area, especially for bigger countries or countries with many islands. Like I think the person asking Indonesia, for example, right, which is a country of the Southern Islands. I remember this remind me of, I think, Irma's presentation where there's this AI robots, right, who can pick different type of waste, which could be alternative solutions. And mentioning about this, we also have a question for Irma. So could you tell us what some of the funding resources in Finland that overseas company can tap for co-development projects? I guess this person is also interested to probably go to Finland to explore opportunities.
Thanks for the question. If we look about the public funding overall, public funding goes for Finnish-based companies. But if a company is 100% internationally owned and has had an office in Finland, is registered in Finland, it is still applicable for government funding. So there is not a percentage that says that you have to have this much like a Finnish ownership or so on. There's a lot of co-creation projects also going on in the public funding, where are both R&D organizations like VTT and then companies and also some international partners going on. It depends a little bit about the size of the company or what kind of they are looking for, but there's a huge amount of those, and I'm happy to share more information about that. That would probably take another hour to go through the topic. And Finland has also one very new thing for, let's say, larger investments. Finland based recently a climate fund, and they have just released the first fund for a company which make protein from the air. So that is another option for, if you want to bring the factory in Finland, then we can talk about the climate fund.
Yeah, and there will also be business matching sessions after this webinar, which will happen in May. So for the audience, if you're interested to find out more, you can feel free to register as well. We have another very interesting question for Mr. Heikki. I guess I'll also open the floor for all of you because it's going to be a big one. It says for chemical recycling, some environmental groups are protesting against the use of chemicals used in the process. So from current observation amongst the big players and product players, is there a large push or is there any push to make chemical recycling to be more green as well?
Yeah. This is a super important question, and it is something which, you know, all the technology developments need to take into account. Specifically when it comes to the use of chemicals in the process, it's not something that would be at the core of what we are developing, because of course in the thermochemical recycling, pyrolysis, not a lot of, you know, chemicals per se are involved in the process. The concerns around thermochemical processing are more related to the overall energy consumption, energy intensity, energy efficiency in the process, and at the end of the day, what it comes to is, on one hand side, the amount of external energy used and the amount, the share of carbon going in that we can capture in the end products that are going out. And that's something what we are focusing on very, very much. And if we look at the technologies we are evaluating, that's one of the, you know, core things. One of the first things that we are looking at is the amount of external energy and the conversion of, you know, carbon going in into product carbon going out. And, you know, in general, I think there are some, you know, a bit misinformed perceptions about that energy intensity in the market, because the technology is, you know, so fast developing, and, you know, some of the publicly available data is just based on a bit outdated information. So, I mean, understandably, it's something where on one hand side, the burden is on us, the industry, to make sure that we come out with, you know, credible and you know, audited, reviewed, externally reviewed life cycle analysis on the performance, and at the same time that we continue focusing on that. So from that point of view, I would say it's something, it's kind of a threshold that every single recycling solution needs to pass. It needs to be efficient, and it needs to be ecological, better than the alternative in all of these angles, while at the same time, of course, no material, no processing is entirely free of any externalities. But, you know, minimizing those and understanding them is at the very heart of our development.
Yeah, I guess to summarize, you know, when we're looking at these problems, right, it's very important to involve all parties, regulators, technologists, as well as business companies to be all involved to co-discuss how we can solve it for our future generations. Well.
Absolutely agree. Absolutely agree. And be transparent about it. Because, I mean, at the end of the day, if you look at what one is selling with a chemically recycled material, we are selling sustainability. We are selling circularity, because from the chemical point of view, actually the even core part of the value proposition is that the product will remain chemically the same, that you know, your plastics will perform like they always did. So the promise is that now they just will come from a more sustainable source, with also the end of life solved in a more efficient way.
Yeah, cool. I guess due to time limit, I would take the last questions for everyone also, you know, whoever wants to jump can jump in. So the question is, when a company collects plastics from rivers, the quality of the plastic is low. So do you see any ways to recycle them efficiently? I believe this, we did recently from IPI, we did an event in East Coast in Singapore as well. You know, we did see so many, you know, waste and also plastic things in the near the beach, in the sea. So this will be a question from me as well. I'm curious to know. So who wants to, I guess, answer it? Steven, you want to?
Yeah, maybe I can jump in.
Yeah.
So I think, yeah, you rightfully pointed out. I think we do encounter a lot of variations in terms of the contaminations, different types of plastic materials, soft plastic, hard plastic, and dirty plastic. That's the most difficult to handle. And of course, I think back to the economic sense of it, you will need to analyze, you need to properly conduct a proper evaluation in terms of how much do you need to clean it, and what are the variations, and what are the suitable technologies that can deal with these variations, or yeah, any value that you can really uncover from it. It may or may not make business sense. And of course, I think for the fundamental part is still reduce, reuse, and recycle. So recycle comes the third. And of course, we would for sure like to encourage the elimination part of it before even thinking about discarding it. So consumer education, again, is at the heart of this to make things work. And yep, there's a lot of different value propositions out there. Of course, I think we would encourage businesses to really consider and study and have a chat with us. We'll be happy to assist and have a conversation with you.
Yep. Heikki, you wanna see your raise hand?
Yeah, if I just may add, from my point of view, when we look at ocean plastics, the key thing for, you know, if you look at recycling solutions, is to create value into our plastic streams so that we prevent the leakage into the environment at the first place. It's a bit of a secondary, you know, consideration for recycling. You know, when it's already in the ocean, kind of how can you solve that? Because if you get it out of the ocean, to be honest, it's not that big a difference if you're then recycling it or incinerating it for energy recovery. But the key thing, and where chemical recycling can really make a difference, is that for those plastic streams for which we don't have any value today because we don't have a proper, you know, way for reusing them, we are actually providing that way, which then provides value for the stream, which incentivizes the collection, the use of the stream, so that it never ends up in the environment in the first place. And I think that's very essential when we talk about, you know, recycling and leakage into the environment. I see that as the core mechanism to address the problem, where of course we then also need to do the cleanup for the plastics that are already there. But, you know, for those, you know, whether it's recycled, whether it's incinerated, it's not that big a difference, because it's still a small fraction of the overall plastics that are discarded every year.
Mm-hmm. Well said. Yeah, I would say, you know, in the end, it comes to every one of us, right, to do the 3R: reduce, reuse, recycle. And we'll see how, you know, in future we can have definitely a greener environment for all of us and our generation. Yeah. I'd like to say thank you to everyone for your very fantastic sharing and also to answer the questions. So, you know, due to time limit, I wish we can continue, but we only have 1 hour and 30 minutes. So yeah, thank you everyone for the session, and also thank you for our audience for your very active participation. If your questions were not answered, don't worry. Feel free to email us. We will for sure to answer you in email. And also, as I shared, right, we will have a business matching session in May, 11, 19, and 20th of May. So where you will get to discover more opportunities for bilateral cooperation between Finland and Singapore in plastic waste management. Yeah, and I guess for me personally, very new to the area, but it did give me a lot of pretty good ideas on how I can reuse, recycle my NTUC fair price plastic bags. So on behalf of the organizing committee, thank you once again, and thank you for joining us today, and we will see you next time. Thank you, everyone.